Everyone, in this video, we'll learn how to find the utility maximizing bundle of goods using the Lagrangian method. Well, don't worry, it sounds complicated, but it's just a step-by-step process. By the end, you'll see it's actually very simple. So, what is our aim here? Our aim is to find the utility maximizing bundle of goods. Let's call this bundle x1 star and x2 star. How do we go about it? There are several steps of which once you get a hang of it, you can solve any problem related to utility maximization. I am starting by taking a Cobb Douglas utility function of the form ux1 comma x2 is equal to x1 raised to the power 1 by 2, x2 raised to the power 1 by 2. I am starting with a specific example so that you can extend this to any Cobb Douglas utility function that you might have studied before. As I always maximize utility subject to a budget constraint, I'm writing a budget constraint P1x1 plus P2x2 is equal to M, where P1 and P2 are the prices of commodities x1 and x2 respectively. So my step 1 here is stating the problem, which is that I want to maximize my utility subject to the budget constraint. And I want to find the values of x and y that maximize utility subject to income and prices. What is my next step? My next step is I write the Lagrangian. The Lagrangian combines the utility function and the budget constraint together. How? I write the Lagrangian function and denote it by letter L. I write utility function, then subtract lambda. What is lambda? Lambda is the Lagrange multiplier. Lagrange multiplier. After writing the Lagrangian multiplier, I write the budget constraint equation, which is simply my P1x1 plus P2x2 minus N. So this is my budget constraint equation. Budget constraint equation. What do I do next? I add another page because I need space. And then my third step comes in. My third step is to write the first order conditions. What are first order conditions? First order conditions are basically taking the partial derivatives. I plan to change the colors and then I take the partial derivatives. So my first partial derivatives is with respect to commodity x1. So I take del L by del x1. How do I differentiate L with respect to x1? In the first part, you use the product rule. You see that derivative of x1 raised to the power 1 by 2 is nothing but 1 by 2 x1 raised to the power minus 1 by 2. and then x2 raised to the power 1 by 2 is as it is, minus, in the second part, I see that p2, x2 and m are not functions of x1, so I simply ignore them. I write the derivatives as 0, but p1 x1 is a function of x1. So lambda, derivative of that term comes out to be lambda p1. And I equate this entire thing to 0. This turns out to be 1 by 2 x1 raised to the power minus 1 by 2 x2 raised to the power 1 by 2 equal to lambda p1. What is my second first order condition? Differentiating L partially with respect to x2, which means I am taking a derivative of L with respect to x2, keeping x1 constant, which means x in the first term x1 raised to the power 1 by 2 will come as it is. Important part is derivative of x2 raised to the power 1 by 2, which is nothing but half x2 raised to the power minus 1 by 2. Then in the second term, it is simply lambda times p2, since all the other terms are not functions of x2. I take that and I equate it to 0. So my first order conditions are basically taking del L by del x1 equal to 0, taking del L by del x2 equal to 0, and del L by del lambda is equal to 0. So the third first order, so this turns out to be x1 raised to the power 1 by 2 multiplied by 1 by 2, x2 raised to the power minus 1 by 2 is equal to lambda p2. My third first order condition is del lambda by del L, del L by del lambda, which is equal to nothing but the budget constraint, because the derivative of that term with respect to lambda is the budget constraint itself. So p1x1 plus p2x2 is equal to m. So now what? I take it equal to 0. I get p1x1 plus p2x2 is equal to m. Now I have three equations, equation 1, equation 2 and equation 3. Three variables, x1, x2 and lambda. I can solve these three variables. But there is another step, which is intuition, how to go about it. If you think of it, looking at equation 1 and 2, I notice that if I divide equation 1 by equation 2, something happens. Lambda lambda cuts across and I get a very simplified version of this. So I get half x1 raised to the power 1 by 2, x2 raised to the power 1 by 2 divided by half x1 raised to the power 1 by 2, x2 raised to the power minus 1 by 2 is equal to lambda p1 upon lambda p2. Lambda lambda cancels out. Half, we need to add another page and I see half cancelling out. My left hand side becomes x2 raised to the power half plus half, because my denominator has minus half, it comes above. I add the powers. Similarly, my numerator has minus half, so I bring it down, I add the powers, I get this equal to p1 by p2, which is x2 by x1 is equal to p1 by p2. This is similar. This is something that we have seen before. Do you recall that this is nothing but MRS is equal to price ratio? In the case of Cobb Douglas, MRS is equal to P1 by P2. You can recall the Cobb Douglas equation that you had taken the general form of. U is equal to x1 raised to the power alpha, x2 raised to the power beta. Its MRS was alpha by beta, x2 by x1. In our case, alpha is equal to beta is equal to 1 by 2. So both the alpha upon beta cancels out and I get MRS as simply x2 by x1. So this means that consumer adjusts the consumption so that utility trade-off equals the market trade-off. The step 5 involves solving for the demand function. From this equation, x2 by x1 is equal to p1 by p2, and the budget equation p1x1 plus p2x2 is equal to m, I can solve for the values of x1 and x2. I can rearrange the first equation and write it as p2x2 is equal to p1x1 and substitute in the budget constraint. So let's do that. P1x1 plus again P1x1 is equal to, it's basically the P2x2, I'm substituting in P2x2 is equal to M. So 2P1 X1 is equal to M and I get X1 is equal to M upon 2P1. This is my X1 star. Then similarly, I can also calculate X2 star. I can substitute my X1 star into this equation P2X2 is equal to P1X1 and get P2X2 is equal to P1 M upon 2P1. P1 cancels out and I get X2 is equal to M upon 2. Yeah, so I have to cancel P1. Yeah, M upon 2 P2. So this is my X2 star. These are the utility maximizing bundles for the Cobb Douglas equation, Cobb Douglas utility function x raised to the power 1 by 2 and y raised to the power 1 by 2. So if I summarize, what did I do? I wrote the Lagrangian, took the first order conditions, divide the first two equations to get MRS is equal to price ratio, use the budget constraint to solve for x1 star and x2 star, and I was done. So remember,